No organization is responsible for the content of this video. All errors and omissions are the sole responsibility of myself, David Iverson. This video must not be your only source of information. Please attend official USSA educational opportunities. Please download official USSA educational materials. Okay, the topic of this video is time of day timing. So what is that? Well, what that is basically all timers are recording the actual time of day of an event. And so then the time on course is equal to the finish time of day minus the start time of day. So here I've got some data, and so I have a whole bunch of data here that I use in various seminars, and let's see, what do I have right there? Okay, so if I look at bib, so this is actual data from an actual race, and so I've got bib 17 and run 1 and started at, well, I really want to do finish minus start. So bib 17 finished at 9:59:38.5506. To the best of my ability to measure, by synchronizing everything with my watch and by synchronizing my watch with the internet time server, just doing the best that I can, to the best of my ability, bib 17 on that day finished at 9:59:38.5506, and they started at 9:58:39.1255. Now I'm going to do another video on just on subtracting times, but I want to just go through this. That's a 1. 6 minus 5 is 1. Here I got to carry over. So it's 10 minus 5 is 5. 4 minus 2 is 2. 5 minus 1 is 4. Then we have a 18 minus 9 is 9. Now this is tricky. I got to carry across a colon. So this is tricky. That was a 2 to make that 18. Now that becomes an 8, but when I carry across a colon, I bring a 6 over instead of a 10. So this becomes an 8. So 8 minus 3 is 5. And then times, I truncate times. So her time was 5942. Now, I should also, because everything is hooked up to my time of day, my secondary system should have the same numbers. And now I know that I've sort of crossed this out, and that's a little bit confusing. But here I've got a 95839.1231. Okay, so this is my primary and this is my backup. And because I synchronized them, they're going to be close, but they're not going to be exact. 95839.12, and then this one is 55, and then this is 31. Now, if I look at the, well, I'm going to do it here. The finish was 95938.5328. So that was a 5.5 in there. So there's going to be more difference in the finish because the finish doesn't have two switches in the same box. It's two eyes that are stacked on top of each other. And so there's going to be more variation in your finish times than your start times. But then I have three systems. So then I can go and I can find the hand time for bib 17. And so my hand time for bib 17 was 9583901, and my finish time was 95938.50. Okay, so now they're still going to be really close. 95839.12, 95839.01, and 9583855 versus 9593850. There's going to be even more variation in these because these are a person standing out in the cold with a stopwatch, just sort of judging when the person goes through the finish. So electronic times going through a start box that has very little variability comes down to 0.02 of a second. Okay, a finish eye, two separate sets of finish eyes have a variability of 0.02 of a second. And then a human being standing out in the cold with a stopwatch has around a tenth, probably about 0.15 of a second variability between those two times. So that is time of day timing. Just a brief. What you should do is you can really help yourself by making sure that your primary system, your secondary system, and your hand timing or third system or tertiary system are all reading time of days, because then you can just match up those times straight across and everything just all matches up if you're doing it correctly. And then to get the time on course, you take the finish time of day minus the start time of day.